hopefully also recording. All right, so we are going to talk about processes and threads, right? And what you've been doing so far in programming, an intro to programming course, usually you write your program and then it runs from the beginning to the end in one way. So that means that you call a function, you go to the function, and then it comes back. So that means for that style of programming, right, we say it's procedural. Right, so usually just follows one line of thought. Now, what usually happens when students take usually programming 3 or operating systems is you have to start being able to think in terms of multiple processes and multiple threads. Right, so that is where we want to get you to. So what I'll do to try and show the way that it's actually currently being done is I'm going to use a program called Process Explorer. So this is Process Explorer. It's a little bit like your task manager. Let me bring the standard task manager up so you can just compare. Right. So anytime a computer is running, if you go to the task manager, you see all the programs that are running there. So for example, this one you can see there's Tasia, Google Chrome, Edge, and so on. So these have been grouped, of course. Right. And there is, of course, NetBeans. There it is. And if you right-click, and this you can easily do, you can see you have some options. Right. Now, if you go to Properties, let's see what this process has. But I don't use this one a lot. Usually when I'm teaching, I tend to use another product. It's free. It's from SysInternals. Right? And if you go to the help, not advertising for him, but I think he did a good job. That's his name, Mark Rusinovich. Right. Now, a long time ago when I was in school, he was making small applications, little applications. It wasn't as big or complex as this one. But I believe what happened was eventually Microsoft got interested in him. I believe he's now working for them. Right? So if you try and download, if you search for Process Explorer and you search, it would actually be downloaded from Microsoft's page. So I think it's actually something useful to know how computers work internally, not just to be. I think that was the name of it's called the SysInternals. That means he knows the internals of how Microsoft stuff works. And a lot of things he's written, and this is one of my favorites, is the Process Explorer. Now, I'm bringing this up so that we can explore what processes actually look like. Right? Now, for every process that is running on a computer, it's just kind of like a database. So that means every process will have a process ID. Right? And so in this one, you can see that there's a column or field here for the process ID. Right? So if I go to NetBeans, for example, let me see if I can find, okay, there's Chrome. Let me reorganize it this way. When you click on a column, it tries to organize by that column. So by clicking on process a few times, it looks a lot like your Windows Explorer, right? And what I want you to note here is, even though in your, like you can see in your menus, so I'm going to bring this window down since I'm recording so people can see, this is your maybe taskbar, and it has listed them. But what most people don't realize is that processes have relationships. That is, one person is running, and then he will start another person, start another person, start another person. So if you look at this carefully, there's when in it. That means when Windows started, somebody started. Let me just collapse this one. And you can see that person started services. Services started SV hosts, and so on and so forth, until Edge finally starts up. Right. So that means that there's a relationship of parent-children between the processes that are running on a computer. Generally, you don't think of them that way. But I think when you start to, if you want to solve bigger problems, you have to start thinking of processes can work together as a group to accomplish a certain task, right? So that's the next step. They have to, if they are going to be running separately, then there has to be a few ways that the processes can communicate with each other. Right? And the one that we saw in this class a lot was the sockets, right? So you can use sockets, you can use pipes. So I'll show at least a few of them. At least the common ones is sockets and pipes. Those are the easiest ones. All right. So if you look at something like this, you can see Windows Explorer. There are a lot of programs that have started under Windows Explorer, including OneDrive, and I think that's a file download manager. And look at Chrome. Chrome has a whole bunch of children. right? So Chrome, there is somebody with PID 12428, and those are the children. And usually what happens is, when a program is running, there are two options, right? Either he does all the work himself, so usually running and doing all the work himself, or he can use threads, right? So when a program is running, I have a question? Oh, yes, stretch. Okay. So that means when a program is running, he has two ways to work. The same way that you also work. When you are doing a task, when you are given a job to do, you can either decide, I'm going to do one thing at a time. I'm going to read a book, and you finish reading the book. Or you can say, I'm going to read a book while listening to music. I know some people believe that they can listen to music and read a book at the same time. But, okay, I find it hard to believe. I think human beings, we actually multiplex. Like, we switch quickly between two tasks very quickly. And even if you take the human eye, we don't see everything at once. I'm told our eyes scan. They actually move from point to point, like the way maybe a computer scanner works. You don't see everything. Yeah, you see a lot, but the way you process it, there is some serializability to it. Right? So it means that even human beings, yes, some parts of us are parallel. Like, you can feel heat and you can taste food at the same time. But at some point, for some of the things, you actually multiplex, especially when you're consciously thinking. Right? So even though someone may pretend that they are multitasking, like I may be typing and talking, but somewhere in my brain I'm switching between the two, unless maybe one is very automatic. Human beings can train themselves to be very automatic, or it's almost like reflex, and they've learned that they are typing a word, they just type it without actually even doing the action. They are riding it back, they're not thinking. So in that way, you can sort of move some of that work to different types of memory. But usually, human beings, especially for high-level tasks, for example, you will not be writing an essay and composing music at the same time. You'll not maybe writing code and writing an essay at the same time. Usually, you pick one thing, right? So when we say programs are running in threads, that means that usually they have two lines or more of execution. So they do this a bit, and they'll move and do this a bit. So that means they are doing two things at about the same time, right? Now, if I have all these programs that are running, right, all of these, and that means that for my computer to actually make use of things, right? And you can see that currently most computers that exist, so let me pick this one and go to the CPUs, right? Most computers that exist have one or two cores, right? And so that means that if you want to make the best use of your computer, you can't just write one big fat program, because what will happen is you just go and sit on one core, like core one. The idea of a core is that, how many of you have done COA, computer organization? You are doing it, okay. So if you take COA, computer organization architecture, you realize that the ALU, that's a certain amount of work. So he may be told do an R, do a division. So if someone says something is two core, usually the idea is that you have two sets of processors that can actually do this addition, multiplication, and that means that hopefully you can do two things at the same time. So instead of having one core, so that's why if you're buying a laptop or something, the single core one is very cheap, dual core a little bit more expensive, quad core, and then there will be like 8 core, 16 core. The more cores there are, the more work you can do. Right? But of course, if you also have more cores, they also can't, there's this trade-off between speed and heat. It's just like a human being. If one person is told to, let's say, run 100 meters, right, and we tell him 10 seconds, that person has to exert a lot of force. But if we pick two people and say, oh, two people, you run 50-50, it will be much less stress on them. That means that they will exert less heat. So as part of computing, usually what we try and do is to try and come up with ways to break problems into other processes and tasks so that you can have things running in parallel. So I know that people have been buying computers, but the reason why we start to think in terms of can we have threads, can we have multiple processes, so that you can actually start to split the work. Right? And how this is relating to this class, in this class we've been doing a lot of socket communication where one process will send information to another process. And that means that we are starting to think in terms of programs that can run sort of independently, where different parts can run. One is doing something and one is doing something else. Right. And now for all of that to make sense, right, that means that we must have some communication. Right. And there are many, many ways that computers can communicate. I'll just pick two in this class, the easy ones, right? And then we'll just see examples, right? So when programs are running, there are, so let me bring command prompt up. This is a shell. Everyone knows command prompt, right? Or knows at least how to get it. Okay, so let me clear. Okay, so in Windows, I think CLS means to clear screen, right? Now, one of the ways, so whenever a program wants to communicate with another program, usually he has to do it with the help of the operating system. And usually what the operating system does is he's going to be a resource manager. Right? So he's the one who handles all the things that are happening. So he has to know about the different files that exist. So anything that is going to use a resource on your computer usually will require you to use some sort of API or function call to get the work done. Right? So people know that if you want to write to a file, you call a function and it opens. Now, the ones you've been doing in programming want to usually for file IO database, but those ones usually would then, it would start to involve the OS, because the OS is the person who manages all the storage, all the space, all the memory. So the resources, so examples of resources, memory, CPU, storage, disk, devices, anything at all, right? Because if the operating system doesn't help to manage it, there will be chaos. So imagine, for example, Word is writing to a file, and I think these days you can realize that, or you should have realized that, if you're using something like Word and you are editing a file and you try to edit it in another program, so let's, for example, try it. Usually it gives you an error, right? Or people have not realized that. Some of the, when you open the same file twice, and one person is, so let me, for example, have this file. I'll say hello, and I try and save it as, sorry, I have a temporary folder, so I'm just going to put it, okay, so this is hello.docx. So Word is editing it, right? Now, if another version of Word, or even another, let's use even Notepad. Let's say Notepad comes along and picks up the file. Because this is, you shouldn't do this. It's disgusting, but I'll just do it anyway. So I've opened the file. It's Word would have understood this and interpreted it. I open a Notepad, so it's a mess. It's just plain code. So I can do this, right? So it says file cannot be saved and it may be protected. Right? So it means that the operating system is actually doing a lot of things in the background, making sure that people don't, or two programs or threads, don't overstep each other. Right? Now, when a program is running, so the other thing that I'll point out is if you pick any program at all, for example, this Chrome, right, and you go to maybe the process, well, the properties, right, you can see there's, first of all, it has an image. That means that there is a binary that it's running from, right? And just looking for, okay, that's performance. So these are various statistics that are being kept. So for example, it's running on the CPU, it's been given a priority, right? So all of these I'll just quickly go through so that these people have an idea of what goes on in the background before we jump into the communication problem. So when it's running, that means that the operating system has an idea that this person has a certain priority. So they do try to schedule them. And there are many types of scheduling algorithms. For example, they can decide to do round robin. Round robin is just, so imagine if you met with your friends and you're eating food, and you don't want one guy to, or one woman to keep eating faster than the others. You can say, let's all use the same size spoon. We take one bite, I take one bite, and we just pass the spoon around, right? Or we can also go with something that is based on some type of priority. So maybe if you're on campus and you're trying to get the bus in the morning, they would say, those people who have an early class can jump on the bus, and those who have a later class can wait. Right? Or if you take in nature, something like vultures, supposedly the hungrier vultures are more aggressive. So there's some sort of adrenaline powered priority, where the hungrier person, maybe human beings too, if you gather to eat, the hungrier person will be much more aggressive. So hopefully that would create some sort of priority. I'm not encouraging violence, just giving an example. Right? So the OS has a way to say there has to be priority, so that it knows that, especially when something is critical, those things that are critical have high priority. Those that don't have low priority. Now, the second thing you notice is there's virtual memory, right? So that means that every program that is running has an amount of memory to think with, right? And if you look at memory, there are two types of memory. This is not required for this class, but just good knowledge to have. There's the physical memory and the virtual memory. And you see that the physical is actually less than the virtual. Right? So virtual memory is like all the things that it can think of, right? And that means that some of it has been moved to disk. Because if a computer is running, there's what? There's memory and the hard disk. So that means at any point in time, it can't actually keep all the programs in the main memory. That's why also usually when you try and buy a computer, you see that the more memory you ask for, the more expensive it gets. Right? So if you say you want 1 gig, very cheap. 2 gig, more expensive. That's of RAM, that is. 8 gig, 16 gig. And even sometimes there's a limit though. So this computer can only handle maybe 16 gig or 32 gig. That means that any program that is running in the on the CPU is using some amount of memory. Right? And that means that the OS is going to say, oh, you're starting, here's some memory for you. You can try and overuse your memory bounds, but what the OS will do is, if you go over your bounds, it's almost like you are told you can only use 1 chair and 1 spot in the class. If you have many more books, what we'll do is, as you bring more books, we'll be moving the books into the cupboards so that we still maintain, and that's like your virtual memory. That means, in addition to what you have on the table, there's some that we've moved aside. But when you realize that you need it, that is, you try and access it. Say, oh, I'm trying to use my economics book. Then we'll go and bring it in. You can use it. So that's the difference between this virtual and physical memory. Now, you can see, one of the things I like about this program is it has I/O, that is input-output, telling us how much reading of data this program is doing. So, for example, this simple Chrome program, this is how many reads it's done so far. You can see it keeps going up. And it has writes as well. So, over time, it will be asking to read and write data. And this program, what I like is it does track it. Right? Now, the other thing that we can do is we can look at threads. Right? Now, what you can see if you open up a program like this is most programs that exist actually have many threads. Even though this is not how generally we start programming, teaching how to program, that there have to be threads. But threads become natural because when you are solving a problem, it's just like maybe in real life. Right? Most organizations that exist tend to go towards creating roles so that they'll say, okay, this person is a cashier, this person is a banker, this person is... And actually, when you started programming, at first you're writing everything in one big, long line. And then after a while, you realize, I can have a function. And you write a function with a method. And that function does a specific thing. And you write another function with a method. And that function also does what? Another specific thing. So that means that as far as programming, it's very easy or much easier if you can modularize your code into threads. Right? So let's now move into, so I hope people understand at least, let's review and then make sure everyone is on the same page. Right? Oh, not IDs. Where are my... Wow, I actually wrote it under here. Okay. So I said, of course, that you have been writing procedural code. And of course, some people said to use objects and functions, procedures. You can call them whatever you want, methods. So you started to organize your code a bit. But still, you were not really writing a program that had two things going on at the same time. Most people still write a program, and they just reason in terms of, it starts from public static void main, it goes, calls a function, I jump there. Right. So what I was encouraging you to start thinking of in terms of is multiple threads and multiple processes. So for example, why would we want to have multiple threads and multiple processes? So from what we've seen so far, why would we want multiple threads and processes? At least in a multi-core machine, why would we want multiple threads and processes? Right. So actually, when you split the work, you can actually have speed up. Because instead of saying, oh, I want one program to do all the printing, all the adding, all the stuff, you can actually say, oh, this program does addition, another program does subtraction, another program does payroll, another one. And they can all run on different CPUs or cores. Right? So that is one. So at least there are so many benefits, but we'll just list some out. That is under multiple processes and threads. So we'll say benefits. So usually, what we are currently having is there are some cores that have what we call hyperthreading. So even though it is one core, the core can actually do more than one thing at once within the same program. So actually, if you have two threads, even if you can't move them to different cores, you can still get some benefit. So the first one, of course, we said was you can improve performance. Usually, if you have multiple CPUs and threads, or some hyperthreading. Now, any other benefits? So there was another one I hinted at, that you've been doing this when you started programming. You break your work into what? It's one of your learning goals, or it's this as one of your learning goals. As a way that you approach problems, what do? You don't usually try and decompose the problem. Right. So part of this project, you actually have to do that. You have to sit down and say, I need to split this into different parts. What are the rules? It's just like, and I thought computer science is not really that complex. You can think of programs like people. So that means that instead of trying to solve everything with one, you have to start asking yourself, can I have modules so that each does a specific function? So you can start thinking of the functions. So sometimes you can break down and say, these are all the things I need to get done. And then you can try and group them into things that work together as a unit, right? So in organizations, for example, I know we usually have a hierarchical model where we say this person reports to. But with social networking and all of that, there are different ways of thinking about people in terms of networks, where we think of, oh, this group is always communicating, maybe they should be together. Or this group is always communicating, they can form a team and continue, right? So that means we really start to think of modules when we have problems. When a problem is very large, then we can break it into pieces. Yeah, actually in your ALU, you did that as well, right? You broke it into different modules. So someone does addition, you pick an adder and you make him do maybe subtraction with a certain bit. You pick another, you add a few more things, you make it do multiplication. So there, or you have one, you can make do shift. I think you've done shifting, right? Shift bits left, shift bits right. You've done that in COA. Okay. So that means that you can now break the tasks off, right? So if you pick it, that means that there's an ALU. Depending on how complex your machine is, you have something like a forwarding unit, a dispatch unit. There are all these units that you would have built within your hardware, right? So that means everyone is specialized to do things, right? And so it does help with problem solving. Right. Now, when we get to communication, so I'll do 2 examples, right? But if you think of communication is actually what is going to make computers useful. Because without communication, I mean, I would start Notepad and I'll be stuck in Notepad. I won't be able to do anything. I won't be able to copy, paste, do anything at all, right? Because I'll just be in here. Right? Because that means that if I type something interesting, like if I typed, shared memory, if I type this, I wouldn't be able to just easily move it from Notepad to, let's say, Word. Because without some way to communicate, but that means that the OS is going to be involved. And remember that the OS is the person who is managing your memory, he's managing sockets, he's managing a whole bunch of things, including the processors themselves. That means that he can, by facilitating communication, make the computer more useful. So without communication, that means the program will start, he only does his work, he doesn't get involved with anybody. But if you pick your browser, your Excel, your Notepad, everybody does communication. He will write a file, maybe you can copy something from the internet, you can get a screenshot, paste it in Paint. All of those are different ways. That means communication is going on because one program gets the data, maybe the screen capture program, and then you paste it in Paint. That means that information has been sent from. So anytime you see information is going from one program to another, there is communication going on. Now I'm going